Hello, my name is Matt, and I am a math teacher in residence at NumWorks. Thank you for joining me today for the Getting Started with NumWorks webinar. Today we will explore how to get started with your NumWorks graphing calculator. If you have a calculator with you, I encourage you to follow along. If not, you can use the free online emulator available directly from the NumWorks homepage or download our free app from your app store. These resources are accessible to everyone at no cost without the need for login or registration. To begin, let's familiarize ourselves with the keyboard on the NumWorks calculator. We'll start with the bottom section, which we refer to as the basic functions. This section includes the number pad and basic operations, multiplication, addition, division, and subtraction. It also contains the parentheses keys. The EXE button is used to execute commands, and the A and S button recalls the previous answer. Notably, the NumWorks calculator does not have a dedicated negative key. Instead, use the subtraction key to indicate a negative sign. Next, let's examine the following two rows, which house most of the advanced functions: trigonometric functions, sine, cosine, and tangent, exponential functions, the natural logarithm, and logarithm. Additionally, there are buttons for the imaginary unit I and pi, as well as the square root, x squared, and x to the power of y keys, along with a comma. At the very top row, we have the shift key, which provides access to the secondary functions of the keys, indicated in yellow. One frequently used function is shift plus pi, which serves as the equal sign. The alpha key allows access to alphabetical characters. For example, alpha 3 yields the letter Y. Following this are the X and T keys, which serve as shortcuts for those variables, and also include theta and K when appropriate. The var key is used to store and reuse variables, functions, lists, and matrices. The Toolbox key is one of the most utilized buttons, containing all advanced functions not assigned to a specific button. Finally, the top row includes the clear and backspace buttons. In the navigation zone, use the up, down, left, and right arrows to move around the screen. The curly back arrow allows you to return or exit menus. The OK button serves as a confirmation key, functioning identically to the EXE button, depending on hand placement. The last two buttons are the home key, which provides access to the home menu, and the power button. Let's begin by powering on the NumWorks calculator and examining the home screen. Upon activation, you will notice that the interface is organized into applications. There are 12 applications available for students to navigate and solve mathematical problems. The first three applications are calculation, graphing, and equations. Following these, there are 4 applications dedicated to statistics: regression, distribution, and inference. Additionally, there is an application for sequences. The calculator also includes a finance solver application, an elements application which serves as the periodic table, a Python coding application, and a settings application. To begin, we will start in the calculation application. Press OK to confirm your selection and enter the application. We will start with some basic operations by adding 2 fractions. First, enter 1/2 by typing 1 divided by 2. Use the right arrow to move your cursor from the denominator and then add the fraction 5 divided by 7. To obtain the result, press execute or OK. You will see that the exact value is 17/14, which is approximately equal to 1.214. Next, let's perform another computation. Enter the fraction 18/4. The calculator will reduce this fraction to 9/2, which is exactly equal to its decimal representation, 4.5. NumWorks always displays 2 values, the exact form and the decimal form. This feature is available even for advanced calculations. For example, let us compute the square root of 50. Upon pressing execute, you will see that the square root of 50 is exactly equal to 5 square root 2, which is approximately 7.07. We can continue exploring other exact values. For instance, computing the sine of pi over 3 and pressing execute will display the exact value, square root of 3 over 2, along with its decimal approximation. I often encourage users to explore additional results after performing a computation. To do this, navigate up into your history. Let us revisit the last fraction computation to illustrate additional results. For the fraction result 9/2, accessing the additional results via the 3 dots at the end and pressing OK will provide more information, including the mixed fraction representation and the Euclidean division for the fraction. Returning to the square root example, the additional results for the square root of 50 will display its position on the parent curve. This allows us to visualize the square root curve and where the value 50 falls on that curve. Similarly, for trigonometric functions such as sine, cosine, and tangent, additional results will provide access to their graphical representation on the unit circle. Additionally, you will see the angle in both radians and degrees. Navigating through the additional results will also display the cosine and tangent values for the same angle, highlighting their interconnections. You can also select a previous answer or input to be used in another computation. Let's go up to select 17/14 and then multiply this value by 19/89. Before we move on from the calculation application, let's review other operations available in the toolbox. Click on the toolbox and navigate through the various options. The primary functions include absolute value, nth root, and log base a. Operations are categorized for convenience. To enter a category, use OK or your right arrow key. For example, the calculus menu includes derivatives, integrals, sums, and products. To exit a submenu, use the back key or the left arrow. There are also sections for complex numbers, probability, units and constants, matrices and vectors, list arithmetic, trigonometry, decimal numbers, and logic. In the arithmetic section, you will find functions such as greatest common divisor, least common multiple, prime factorization, and quick access to mixed numbers and other fraction parts. Once you find a function you want to use in the toolbox, make sure it is highlighted and press OK. For example, let's press OK on the greatest common divisor. This pulls the function into the input field to be filled. Let's compute the GCD of 15, 18, and 21, which yields a result of 3. Next, we will return to the home screen and navigate to the Grapher application. Press OK to enter it. You will notice that this application is divided into 3 tabs: Expressions, Graph, and Table. The Expressions tab is where you input the expressions you wish to graph. To begin, press OK on Add an Element. This opens up a place to start typing, or you can select templates to see our pre-built templates that make typing in various types of functions even quicker. For example, you can graph equations, functions, inequalities, inverse functions, piecewise functions, conic sections, parametric equations, and polar functions, all without changing the mode. For this example, let's start by selecting the f of x equals x function template to create a function. Press OK to proceed. This allows you to quickly edit the template. Let's enter x squared minus 13 and press execute. You are not limited to using templates. When you select Add an Element, you can immediately start typing an expression in any desired form. For instance, we could type the expression 3x plus 4 and it will default to y equals for a single variable expression. Now both your polynomial function and your line are included in your expressions. You could even type an equation in standard form with NumWorks. To view the graph, navigate down to Plot the Graph and press OK. In the Plot the Graph section, you will notice several features. Firstly, the NumWorks Graphing Calculator prioritizes auto zoom to ensure all points of interest are visible. These points include intersections, zeros, and maximum and minimum values. You can use the left and right arrows to trace the function, snapping to these points of interest. For example, on a quadratic function, you can identify its zeros, navigate to the intersection of the quadratic in a line, and observe points where features overlap, such as a minimum and a y-intercept at 0, -13. To switch to another function, toggle up to move the cursor to the line, allowing you to trace and identify its points of interest as well. To zoom, use the plus and minus keys for quick adjustments. Additionally, in the graph view, you can navigate up to reactivate auto zoom, set your axes manually, pan the graph, and perform calculations. Next, let's perform some calculations on the quadratic function. Ensure your cursor is on the quadratic curve. You can either press OK or use the toolbox to open the calculation menu for the function. In the Calculate on f of x menu, you can input a value for x or f of x. For example, if you want to determine when f of x equals -9, input the value and press Execute. The calculator will show that f of x equals -9 when x equals -2. Due to the symmetry of quadratic functions, there is another point where the function equals -9. Use the right arrow to toggle to this point, then press OK to exit this window and return to the Calculate menu. In addition to changing values of x and f of x, the Find menu offers various features. Pressing OK on Find allows you to locate different characteristics of your f of x function. For instance, you could find x given y, identify intersections, maxima, minima, and zeros. You can also add a tangent line to the curve, calculate integrals, and even determine the area between f of x and y. For example, let's find the area between the two curves. Press OK. You are prompted to select a lower bound. You can use your arrows to navigate to a value on your number pad. Let's input -2 for the lower bound and press Execute to confirm. Then for the upper bound, I'll scroll to the right until I reach the intersection and press OK. Here you can see the area between the curves. Press OK to exit the area between curves and return to the calculation on f of x. The last menu to explore is the Options menu. This menu allows you to change the color of the function, toggle the values and graphs of the first and second derivative, adjust plot restrictions, choose whether to display the function in the table and graph, and delete the expression altogether. Next, let's examine the table of values for this function and equation. Navigate up and over to Table and press OK. In the table of values, you will see the input value x, f of x, and the y values for the expression y equals 3x plus 4 displayed. In the table, you can input any desired value. For example, if you want to input 11 instead of 0, enter 11, press Execute, and the table will update accordingly. You can also toggle between exact results and decimal forms and set the interval settings. The interval settings allow you to specify the starting x value, ending x value, and the step size for your table. Let's proceed to our next application on our home screen, Equations. To enter the Equations application, press OK. Here, we can add equations and begin typing immediately. For instance, I can input 3x plus 7 and set it equal to 23 by pressing Shift followed by pi to get the equal sign. Press Execute and navigate down to solve the equation, which will provide both the exact form and a decimal approximation. Now let's explore additional functionalities. Clear the current equation, then press OK on Add an Equation to select a template. For the next example, I'll use the template x plus y equals 0 to construct a system of equations. Press OK and modify this template to the desired linear equation. For example, input 5x plus 7y equals 9 and press Execute. To add another equation, type it directly. Use the alpha key in 3 for y, Shift followed by pi for the equal sign, and input 2x minus 13, then press Execute. After entering two equations, the calculator recognizes that we are solving a system of equations. The button will update to solve the system, and pressing OK will yield both exact values and decimal approximations. Let's proceed to our next application, Statistics. Press the Home button and navigate to the right to select Statistics, then press OK. The Statistics application is similarly structured to the Graphing application, featuring 3 tabs: Data Input, Graphing, and Statistics. In the Data Input tab, you can enter up to 3 data sets. Begin by inputting data into V1. If you wish to follow along and input the data yourself, please pause the video to ensure you have sufficient time. Once the data is entered, use the back arrow to quickly navigate to the top banner. Move to the Graph tab and press OK to view the graph options for your data set. Available options include a histogram, box plot, cumulative frequencies, and normal probability plot. Start with the histogram by pressing OK. This will generate a histogram where you can toggle through each interval. As you navigate through the bins, the bottom banner updates with the interval, frequency, and relative frequency. In the histogram settings, you can modify the bin width and the starting X value. Additionally, under Type, you can switch between different types of graphs. Press OK and navigate down to the box plot. Here, the 5-number summary is displayed in the bottom banner as you toggle through the box plot. Minimum, first quartile, median, third quartile, upper whisker, and maximum. If you prefer not to display outliers, navigate to the settings and toggle off display outliers. The outlier will then be included in the whisker. Finally, let's explore the Stats tab to review all statistical offerings for one variable datasets. This tab provides both symbolic representations and full vocabulary terms for each statistical measure. If you need to save any of these values, you can do so quickly with the var key. Pressing the var key will bring up our store function, and you can use the alpha keys to use your preferred variable. Let's return to the home screen and proceed to our next application, Regression. Navigate to the Regression application and press OK. This application is ideal for analyzing bivariate datasets. As before, you can enter up to 3 different datasets into the X and Y columns, and then examine their graphs and statistics. Begin by inputting some data. If you are following along and wish to enter the dataset, please pause the video to ensure you have enough time. Once the data is entered, navigate to the Graph tab. Use the back arrow to quickly access the top banner and move to Graph. The data will be displayed immediately in a scatter plot. As you toggle to the right, you can move through the data set, and the bottom banner will display the X, Y, and R value. To add a regression model, press OK or the Toolbox key to access the regression options. Select the desired regression model and press OK to add it to your data set. For example, adding a linear model will overlay it onto the scatter plot. You can use the up and down arrows to navigate between the data set and the regression model. Once on the model, you can scroll left and right to view different X values, predicted Y values, and the regression equation. For more detailed information about the regression, again press OK or the Toolbox key. This will allow you to change the model, view the regression equation, access the R-squared and R values, create a residual plot, and make predictions. For instance, to see the residual plot, click OK on Residual Plot. That's all you need to do to bring it up, and you can navigate through the residuals to see each value. Use the back arrow to return to the menu. Finally, let's explore the Statistics tab. Press OK to access the statistical measurements for your bivariate dataset. This tab provides both symbolic representations and full vocabulary terms for each statistical measure. Let's press the Home button. Navigate down to continue with our statistics theme and explore the next 2 statistics applications. First, let's examine the distributions application. This application is ideal for working with various probability distributions. You can select the desired model to follow. For this example, I will choose a normal distribution and press OK. On the distribution, you will be asked to define the parameters, mean and standard deviation. I will use a mean of 128 and a standard deviation of 4, then press Next. On this screen, you will see the probability curve, the probability statement at the top, and a reminder of the mean and standard deviation in the banner. This allows you to input the probability that X is less than or equal to a certain value. For instance, input 137 and press Execute. This action will shade the probability curve and provide the probability output. This function also works in reverse. You can input 0.25 for the 25th percentile, press Execute, and the application will find the X value that satisfies this probability statement and update the shading accordingly. If you are interested in more than just a less than or equal to inequality, navigate to the drop-down menu, press OK, and choose from different shading options. For example, to find the top 5%, press OK, navigate to the appropriate option and input 0.05. This will determine the X value corresponding to the top 5%. Next, let us examine our final statistics-themed application, Inference. Press the Home button and navigate to the Inference Application. This application includes both significance tests and interval tests. Let's perform a one-sample t-test for a mean based on the sample of data we already input into the statistics application. Press OK on significance test, OK on one mean, and OK on t-test. Let's assume the null hypothesis is 16.5, and the alternative hypothesis is mu is not equal to 16.5. From this screen, you have two options. First, you can choose to input the summary statistics if you were given those, but we will use a dataset. Within this option, you can select the dataset already defined in the statistics application, or you can add or edit your data here. Scroll down and select Next. Here, you will see the calculated values for sample mean, sample standard deviation, sample size, the test statistic, the p-value, and the degrees of freedom. Selecting Next will provide a graphical representation of the test on the curve. You can also zoom in for a clearer view if needed by using the plus button. Holding the back arrow will quickly return you to the main screen of the Inference application to quickly begin another test or confidence interval. Let's transition from statistics to our sequence application. Press the Home button, navigate to the Sequence app, and press OK. The Sequence app is organized into 3 tabs: Sequence, Graph, and Table, similar to other apps. To input a sequence, press OK on Add a Sequence. For this example, we will create a recursive first-order sequence using the U sub n plus 1 notation. Press OK to proceed. Now input your sequence. You can also use the Toolbox key to access U sub n, V sub n, and W sub n in addition to the normal Toolbox functions. The XNT key will also default to n in the Sequences app. For this example, let's use an arithmetic sequence. Enter U sub n minus 4 and set the starting value to 10. The default starting index is U sub 1, but you can change this by navigating and pressing OK to modify the sequence type and the first term index. If you prefer the first term to start at U sub 0, enter 0 and press Execute. You can also adjust settings such as Show in Table and Graph, Color, and delete the sequence. Use the back arrow to return. Notice that the index now starts at U sub 0. Once your sequence is created, navigate to Plot the Graph and press OK to view a graphical representation of your sequence. Similar to the graph application, you can edit axes, navigate, and perform calculations. Navigate to the table to view the sequence values. This table is editable. If it currently displays up to the 10th value, you can extend it to the 15th by entering 15 and pressing Execute. You can also set the interval in the table of values. Another feature of the Table tab is that you can add a column for the sum of terms. Navigate to the U sub n header and press OK to see this toggle. Toggling it on and pressing the back arrow will now add a summation column after U sub n. Let's press the Home button and quickly review our remaining applications. The next application we will explore is the Finance app. Navigate to the Finance app and press OK to open it. You will have the option to work with either a simple interest problem or a compound interest problem. Let's select the simple interest option and press OK. To solve a problem, choose the parameter you wish to solve for. For instance, if you want to determine the initial principal, press OK. Input the relevant data for your problem and then hit Confirm. The application will calculate the initial principal for you. Note that the flow of money is indicated by the negative sign. From our perspective, any money that goes away from us is made negative, and money that comes to us is positive. Next, let's explore the Elements application. Press the Home button, navigate to the right, and press OK. This will open up the periodic table. The periodic table allows you to navigate through different elements, with the bottom banner displaying the element's family. Pressing OK on an element provides more detailed information about it. To move between elements, use the plus and minus keys or the left and right arrows to move to the next element. Let's go back to the previous screen. The final feature to explore in the Elements tab is located at the bottom, the 3 dots menu. Currently, the periodic table is color-coded by element family. Pressing OK here offers different options for color-coding the periodic table. For example, to color code by melting temperature, simply press OK on melting temperature. The colors will update accordingly, with the bottom banner now displaying the melting temperature. Darker colors indicate higher melting temperatures, while softer colors indicate lower melting temperatures. Navigate to the home screen and open the Python application. Within the Python application, you will find preloaded scripts as well as any scripts you have uploaded to your calculator. You can use the Python shell to execute your scripts and explore the Python code by pressing OK to read through the scripts. For this example, let's use the polynomial script. Upon entering the script, you will see that the function roots has been created. The script checks the discriminant to determine whether it is positive, negative, or 0, which dictates the subsequent calculations. Let's back out of this and execute the script. By selecting the three-dot menu, you can choose Execute Script to run the code. While you can type directly using the alpha keys, accessing created functions is simplified with the var key. Select roots and input the values 1, 8, and 16 to obtain a solution of -4. Repeat this process with values 1, 8, and 7 to get two solutions, -7 and -1. Although you can code directly on the NumWorks graphing calculator, I also encourage you to visit the Python script section of our website for additional coding opportunities and resources. Scripts can be loaded onto the calculator from your saved scripts, and scripts created on the calculator can be transferred to the website for permanent storage. For our final app, let's press the Home button and navigate to the Settings application. This app offers several useful features. Firstly, you can change the calculator's angle settings from radians to degrees or gradients. Additionally, you can adjust the result format and switch the complex format between real, Cartesian, and polar. Another important feature in the Settings application is Test Mode. This mode allows you to disable specific features of the calculator to restrict student access. Within Test Mode, there are two options: pre-built exam modes for state tests and IB exams, and a Press to Test mode where you, as the teacher, can control which features to disable. Simply toggle off the features you wish to disable, then scroll to the bottom and activate Test Mode. Activating Test Mode will lock the calculator in the selected test configuration until it is reconnected to a computer. When in Press to Test mode, the icon at the top of the screen will change to include a small graduation cap, providing a quick visual indicator that the calculator is in test mode. You can also apply these test settings to multiple calculators simultaneously by connecting them to your computer and selecting Test Mode under your profile's drop-down menu. Thank you so much for joining me for this webinar. If you have any questions, please feel free to ask them in the comments below or email us at contact@numworks.com.